Hello and welcome! In this video, we'll be going over some of Solana's core technological concepts so you can kickstart your development, become a power user, or just expand your blockchain knowledge. Introducing Solana, an open source project implementing a new, permissionless, state-of-the-art blockchain that is able to achieve a very high number of transactions per second. This is achieved by, first of all, using Solana's own consensus algorithm named Proof of History. It can be implemented using a mechanism that has existed in Bitcoin's source code since day one called nLockTime that post-dates transactions using block height instead of the usual timestamp. Block height, or the amount of blocks before the current one, turns out to be a cryptographically secure way to say time has passed. Solana uses a far more granular function called SHA-256 hashchain to checkpoint the ledger and coordinate consensus. Once nodes are able to trust time, decades of distributed systems research become applicable to the blockchain technology. First proposed in 1981, a technique named optimistic concurrency control enables a database to also replicate itself and maintain high availability without significantly compromising its transaction rate. The Solana project demonstrates that this technique can be efficiently applied to the blockchain on an adversarial network with a theoretical limit of more than 700,000 transactions per second. And this is on a standard gigabit network. In a 40 gigabit one, more than 28 million transactions per second can be theoretically achieved. Solana's architecture goes on to satisfy all three desirable properties of a blockchain. It is scalable, secure, and decentralized, also supporting safe, concurrent execution of programs in programming languages such as C or Rust. Now that you know what the Solana project is all about, let's delve into its core practical principles. A Solana cluster can be defined as a set of independently owned computers working together or against one another to verify the output of untrusted user-submitted programs. From the outside, the cluster can be viewed as a single system and utilized anytime a user wants to preserve or interpret an immutable record of events, such as tracking which computers did meaningful work to maintain the network, or verifying possession of real-world assets. During any of these processes, the cluster produces a record of events called the ledger, which will be preserved for the lifetime of the cluster. As long as a node has a copy of the ledger, the output of its programs are reproducible, regardless of when or who deployed them. Sol is the name of Solana's native token, which can be passed down to nodes in exchange for running on-chain programs or validating their outputs. A Sol is subdivisible by up to 1 billion times, and a billionth of a Sol is called a Lamport, named after the Turing Award-winning computer scientist Leslie Lamport, Solana's biggest technical influence. As a Solana developer, you can subdivide your program into two parts: a set of decentralized, blockchain-based programs that run behind the curtains and can be audited, and then there's the web app itself that interacts with your users. The basic production flow of a Solana app goes something like this. First of all, developers deploy their decentralized code directly to a Solana cluster. Then, users cause your web app to interact with the Solana cluster by sending it transactions with one or more instructions. The Solana runtime is in charge of correctly passing down those instructions to our previously deployed programs. An instruction can be, for instance, transferring 1,000 Lamports between accounts given a condition is met. Instructions are then executed sequentially and atomically for each transaction. That is, if every instruction checks out, changes are committed, and your program has successfully been executed. Now, if any single one of the instructions is invalid, all account changes in the transaction are completely discarded, and the state of execution goes back to how it was before. So this is going to wrap up our Solana Core Concepts video. I really hope you managed to conceptualize what was presented here and liked improving your blockchain dev skills, because there are many more videos to come. If this video helped you out, please leave your like and don't forget to subscribe to our official YouTube channel and enable notifications so you don't miss out on any future uploads. You're more than welcome to join our community. Follow Solana on Twitter @Solana and join the Telegram channel using the link t.me/solanaio. You can read up on more Solana related content by following the link medium.com/solana-labs and also join the official Discord channel by going through the link located in the official website. It was a pleasure having you here. Thank you so much for watching and I hope to see you on the next video. Bye!